from yesterday and everything that we discussed so far, what would the difference be? Everything that we've discussed so far, what would the difference be between pentane and cyclopentane? So it's a ring structure. So what does that mean then? Yeah, it's the geometric shape, whether it's a pentagon, a hexagon, octagon, heptagon, nonagon. You probably don't have to know anything about 8 because 7 is hard enough to draw. 8 side figure would be probably a little easier. Okay, so as we continue past these regular alkenes, we substitute something on that ring. There's a substituted hydrocarbon, as you can see, and there are different examples of that. And we talk about this, I think we did. We're past this, okay? So, these are different organic families. We call acids and alcohol. But if you were to receive the flu shot or any type of vaccine, whoever's administering that vaccination, whether it's a nurse or some sort of medical technician, they may rub alcohol on your shoulder. And of course, we had discussed yesterday that has different characteristics than just regular alkenes on their own. So what that means is if you see this OH group right here replacing any single hydrogen on there, it is now an alcohol and no longer an alkene then. So if we're discussing, for some reason, I just always use 3-carbon compounds. We're discussing propene. Okay, propene. We know it's 3 carbons, but what organic family would that be? Just by listening to it, it's an alkene. So that tells you that somewhere in that compound there is a what? It's an alkene. Okay. So as we're talking about that, how many of you are thinking, I had no idea that's what that was? Because if there is, we need to address that sooner rather than later. Okay? Because again, like in that relay race, okay? Luckily, some of us maybe get the baton second or third, and we're already ahead. Just don't give up the lead, right? Because there's nothing worse than getting that baton and you're already behind. Okay? And we talked about it with volleyball, basketball, football, any one of those. Okay? More often than not, in other words, it doesn't happen very often. Yes, you can possibly win the game in the first half. I mean, yeah, you got to play all 4 quarters possibly, but it's a heck of a lot more logical to say you're probably going to lose the game in the first half before you would ever say you're going to win. What that means is sometimes it's really, really hard to come from behind. I think you would agree, yes, no, just football or basketball, just pick one. Okay, so if we're talking about basketball, I talked to the seniors about that when it was during the basketball season. Let's say it's a close game, it's 26-24 at halftime, you're down. Okay, you get the ball to start the 3rd quarter, you turn it over. The opponent scores. You bring the ball down again. You turn it over. You give up a layup. 3rd time. Turn it over again. Now they score a 3-pointer. Okay? So that's 4, 7. You're down by 9 points, and you're not even halfway through the 3rd quarter. Okay? Yeah, there's still more time to go, but I think would common sense tell you sometimes it's pretty hard or difficult to come from behind? Does that make sense? My point is, if you're falling behind in this, you're making it a lot more difficult on yourself than what you have to. That's where it's a good idea to come in and ask for help. Whether you find someone older or someone else in the class that can help you. Or you can go to the science channel and catch up with that rather than having someone else's paper, right? Fair enough. Okay. So where do you suppose you see this compound right here? Ethanol. Where might you see that? Maybe not every day, but for those of you who drive, possibly once a week. Yeah, unless you have a moped or a dirt bike that you can ride, that you get very good gas mileage. Of course, ethanol, sometimes you could refer to that as an additive to gasoline. But that's not the only place that you would see ethanol. Okay? As you can see, when this is fermented, okay, this sugar then can be converted to alcohol. Okay? That's in what we call a distillation process. We're obviously not going to go into something like that. Okay. After this, we'll go one further. Okay. Then for those of you who were here, maybe you're done. Those of you who are absent, okay, it gives you that opportunity to work on these. We're going to go over some examples of what we see up here. So as we can see, vocabulary, is that due today? No, it says due the 26th. If you do not have that done, okay, some of you probably work on that right away, right when you receive, and that's fine. Okay. There again, that's just another thing to add to the list if you do not have that done. So, as it says here, naming alcohols and acids. Now, that's not going to make much sense to you right now. It just says that it's similar. We'll show you what we mean here. So we'll add this information at once. Some of you probably filled up so much with pancake, you didn't have dinner. That's not accurate. Or is that not a problem? So I'm guessing if it's not tomorrow, it must be sometime next week. Who's driving their tractor to school? Anybody? Isn't that coming up for your FFA activities? Up in the case international driving to school. You don't want to take that long. I don't know how long. What would you think? Half hour? No, not half hour. 20. Bring your friends with you. Is there room enough in there? You want her? Would you trust her to drive? Yeah, probably. Okay, like I said, one more. Okay? And then we'll go over some examples up on the board. And whether it's this class or general chemistry or even organic, I've always used, I don't know why, I mentioned earlier, I've just always used 3 carbons for example. Recorded that Sioux Falls maybe had 35 to 107 inches of rain on the north side. So I'm thinking the further north you come out of Sioux Falls, maybe the less you have received. For some of you farmers, you think it's going to be about time we need to get into the field. Fortunately, Mother Nature isn't allowing that to happen. It'll all work itself out. You just might have to miss school. You're sitting in, drilling in beans instead of sitting in class. Is that better?
Yeah.
Can you plan straight? You don't need to. It's just GPS, right? Could you plan straight? So that if this guy goes down, what's this thing doing on the far right side as you're planting? What? So it's one thing to say it's marking, but then once you pick it up and turn around and yeah, this one drops down. But what's that marking? What do you put in that drop? I think it's the left. If your right side is down, it's the left tires that go on there, left back. Does that sound right? I don't know. I've never planted this. All right. Does everyone have this information at once? Okay. So we're not done for today. I want to go over some of these examples. Okay. So as we continue moving forward then, okay. The simplest organic compound, simplest hydrocarbon. It's an alkane. Methane. What's the formula for methane? Okay, so this is how we started this chapter, okay? If there's nothing else written on those dashes, what does that mean? Those are hydrogens on there, okay? So, if we change that suffix to ene, can we draw methane? We just drew methane. Who can draw methane? Shaking your head no. Well, this young lady can do it. Certainly you can. You're going to shake your head no? How about in here? Someone draw methane. No one even wants to try? Well, that's right, because you can't. Correct? Yeah, you can't. Does anyone think they know why? Yeah, there's nothing to double bond to. So if we're going to draw ethene, what would that be? How many carbons is that? It's 2. Okay. Okay, so again, this is what we're drawing. What is that telling you? The organic family, which means what? It means it's an alkene, which is what's happening between these two carbons. There's a double bond. Okay. How many more bonds does this carbon want? Okay, it's got 2 here, so we put 2 more. If you go up and down, that's fine. This one has 2, then so does that one. That is Fe. Okay, so from what we had just discussed, okay, okay, does it look like those two examples of 3 carbon compounds? Does it look like they are written correctly? Yes, no? Okay, yeah, both of them are compounds that we could discuss. And what would this top one be called? Propane. Okay, something that many of you people are familiar with because you fire up the gas grill. I mean, some of you may have natural gas or grill. It's probably not very common, but it's possible. Okay. So if this is propane, okay, again, the organic family, it's an alkane, it's single bonded, and that's how many carbons are. Okay, here we see 3 carbons, so what is our prefix, or PROP? Okay, then what is that triple bond? Tells you the organic family, which it is a what? Alkyne. So what is the suffix then? Again, organic family here, number of carbons. Okay, with everything that you see here, left outside, let individuals get comfy here. Well, play catch up. You two, left outside, we on the bus. Left middle, middle, right middle, right outside. Okay, so now, if we wanted to change this propane to propanol, okay, that is an example of a substituted hydrocarbon, which means somewhere on this structure, we're going to replace that because it's a substituted hydrocarbon, just like when you have like Mr. Paulson in for Mr. Williamson, or you have a different substitute in for Mr. Husby, whichever, okay? So that means somewhere on this compound, what did it say the suffix would be for an alcohol? I think it's OL. Okay. Okay. So again, notice that we've always followed this pattern. And for those of you who weren't here today in this some class, you can go to the science channel. You have that opportunity to do so if you want to go back and see what we have covered. It's totally optional. All right. So when we put these in a box, does this help? Do you like looking at it in this analogy? It explains what the organic family is. It tells you what the number of hydrocarbons there are. Okay, so if that is the case, which it is, this is telling you the organic family, OL. Okay, and you correctly said, what does it mean if it's an alcohol? Somewhere on this compound there is a what? A hydroxy group or OH. Okay, left outside, Still on the bus. Left, middle, middle, middle,
Oh, yes.
right, middle, right outside. I see some no expressions or shrugging our shoulders. That tells you if you are having problems, you still have time to do that. Okay, so you tell me 1, 2, or 3. What'd you say? 2. So top or bottom? Okay. So what do you suppose we're going to put here according to that terminology? Or an OH means the same thing. So again, this is a substituted hydrocarbon. It used to be a hydrogen. Now we just have an OH on there. So that OH or hydroxy group has substituted that hydrogen. Okay. Last thing before we go on some other examples. Okay. Okay, this is on the very last thing that we had mentioned. Okay, propanoic acid. All right. What knowledge have you learned so far that you can tell me about this? Okay, it's an organic acid, but what can you tell me? 2 things about this word right here. In other words, look at your pattern here. Okay, 3 carbons. So that took care of this. This is your organic family, which it said, how do you know it's an acid? It tells you, students would like to say COO, because it's COOH. Okay? This is a little different because it's got a double bonded oxygen on there somewhere. So, left side or right side? Okay? So the left side, that COOH. COOH. That means it's an acid. The rest is just single bonded carbons and hydrogens. Okay? So, that's a single bond. That's a single bond. How many hydrogens go on here?
2.
How many hydrogens go on here?
3.
Okay. So again, when it says COOH, that means you're dealing with an organic acid. Okay. Oh. And it doesn't matter whether it's on the right side or the left, it occurs on the first carbon. Because remember, what sport have we talked about when it comes to numbering these? Golf. And the idea is to have the lowest possible number. So in order for that to happen, it has to be on the first carbon. We can also put it on the right. Okay? So COOH, CO, and OH. Okay? What is the name of this organic acid? Which one? Because it has how many carbons? 6. Okay? So, and what prefix, not prefix, which suffix denotes an acid? Okay? Just like that, our organic family. We just say acid. Okay? So, you have a very good understanding of this. What is the simplest organic acid you could draw? Okay, that's kind of tricky. That's why we're going over it together as a group rather than just saying, hey, name this. Okay, you say that again. You're saying it correctly, and you say what? Ethanol? Okay. Well, let's take a look. We're basing it off of this. So we said F. So how do we change this to ethanoic acid? Okay, we got to get rid of that double bond because everything's single bonded except for an oxygen. Okay? So left or right? Okay? So what do you want to put on top? You can put it on the side too, but what do you want to put on top? And then what goes over here? Okay, is there anything else we need to do? We need to add another hydrogen right here. Okay? Well, what about if we just did that guy right there? It was a low down dirty trick on my part. That's why I said let's go over that together. Okay? So no, it is no longer ethanoic acid, but rather what? Methanoic. And it does have a common name, very much like this. That, or what's a different way of writing that? Put a circle in the middle. Okay? You can also call this, you can also call that cyclohexene if you wanted to. Okay? Because what you're saying is there's a double bonds in there. This is telling you that there's 6 carbons, and this is saying that it's in a ring structure. So that's the scientific name. But what is a common name for this? Benzene. Okay? For those of you who go on further to take organic chemistry, some of you may, some of you might not. You take physical science, biology, and then either general chemistry or zoology and say, I've had enough science. Because science isn't for everybody. We can establish that, correct? Some of you are possibly thinking there's many other places in this building I'd rather be. At least be in the building, not at home. There's other places you'd rather be in the building than in the science room. That's fine. How boring would it be if everyone had the same interests? Everyone thought the same. I think that'd probably be pretty boring. And another thing to think about, if you always got what you wanted, you'd always be happy. Well, that's great, right? Sure. But how do you know how to deal with sadness if you had the opportunity to always be happy? If something happened, well, then sometimes you got to deal with sadness. Right. So, with that, you could say change this from ethanoic to, okay, it's either methanoic acid, also has this, formic acid. Now, that's entirely up to yourself. There's many other different applications. Has anyone ever heard of Alfred Nobel? You've heard of it. Why does anyone think they know what's named after Alfred Nobel? Nobel Peace Prize. Does anyone know what Alfred Nobel invented. If you were working in a quarry, the only way you could start shattering rock would be one of two things. You could take a pickaxe and a sledgehammer and start swinging away. Then a certain type of technology had moved forward, but it was really, really unstable, killed many, 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 many people. That was nitroglycerin. Then Alfred Nobel, let's make this stable compound. Dynamite's the common name. You would see that in any type of quarry, possibly Del Rapids, in Sioux Falls. I mean, if you have the opportunity to be outside at certain times, you can hear the blasting in the quarry. They're probably using dynamite. But what I'm getting at, okay, who knows who Wile E. Coyote is? If he had a business card, if you had the opportunity to see some of his cartoons, he has a business card, and it says Wile E. Coyote, and under that, in quotes, it says genius. I don't know. I would say Wile E. Coyote is a genius. Agree? The most common explosive he uses is dynamite. Everything. That's the common name is dynamite. Does anyone know what the scientific name is? Because it would say this on all of his explosives. T something. TNT. That's just an abbreviation. Okay? So, again, for some of you who go on to take organic chemistry, okay, you could call that methylbenzene. That's the scientific name. You could also call it toluene. That's a common name. Okay, so toluene. Okay, well, that's quite a stretch from dynamite, isn't it? Well, we're not quite done yet. If you were to go through a proper reaction and put some of these nitro groups on there. Okay, if this is a nitro group, which it is, so is that one, how many of them do you have on that ring? So what does it mean to have 3? What's the prefix for 3? Not pro, but rather what? Yeah, drop. So or known as that. That's how you would always see it. TNT, right? Even on the cartoon. What that's standing for is this molecule right here. The reason that was such a leap forward is that you could take, if this was dynamite, say, who can we pick on? Catch, dynamite. Did that just blow you up over there? No, because it doesn't have a fuse on it. Okay? If you have a fuse attached to that dynamite, well, yeah, then it's going to ignite and explode. So what that means, if that was nitro, and you throw it and you catch it, that might be okay. You throw it and you drop it, now we got a whole row of students who may have just perished from an unplanned explosion. That's what nitroglycerin would do. So when Alfred Nobel came along and produced this trinitrotoluene that could be moved, transported, placed, and you place the dynamite where you want it, you put the fuse in it, you're allowed to leave, and maybe if it's a wick or a fuse, maybe, I don't know, 2 feet long, it gives you opportunity to get probably 50 yards away. Maybe that's enough. But they don't do it like now. Sometimes you see that you pull the deal up and you press it down. It pushes electrical charge along. But before you do that, you get to say this term, fire something. Fire in the hole! Boom! That'd be fun to be a demolitions person, wouldn't it? Dangerous. It'd be probably fun. All right. So, we will pick up with this next time.